Alright, so today we're going to work on the stat practice. Question 1, the following data set represents the number of days from mailing to delivery for the package. And you guys have a data set right here. So I provided a free calculator on eClass for you guys. You can plug it in. So remember, we're going to go to stat, add it, and put the data in. Here, 15, 11, 10, 13, 1, and 13. Okay, so you should have 11 pieces of data. Okay, so now we're going to go back to stat, move it over to calc, press enter in the first version. Make sure that the list matches the list you put your data in. Enter, and here's all the information that you need. So we have our mean, we have our standard deviation here. If we scroll down, we're going to have our median. So let's go back. So our mean was 9.27. Find amount, which is the most occurred number. So I can see 13 repeats 3 times. Everything else repeats twice. So 13 is our most occurred number. Standard deviation was 4.47, so 4.5. And the median was 7. Okay, now the range is the maximum minus minimum. So again, we're going to find our maximum. Our minimum right here is 1. And our maximum is going to be, let's scroll down. Maximum is 15. Okay. Our minimum is 1. Maximum is 15. We're going to subtract 15 minus 1, which is 14. So our range is 14. Alright, next question. Jenny is competing for a promotion at work with 200 other people and took a practice exam. The practice and the real exam are based on 3 categories: instructional design, data processing, and design technology. The good thing is that Jenny was above the mean of all 3 categories, but she has 2 weeks to study. She wants to put more effort studying her weakest category. To find out, she can calculate the z-score. So a reminder, z-score is x minus your mean divided by standard deviation. So for each of these categories, we're going to calculate the z-score. Z-score for instructional design is going to be 34 minus our mean, which is 12, divided by 4.3. That should give you 5.12. The z-score for data processing will be 11 minus our mean, divided by 2.2. That should give you 2.27. And the last one, z-score for design and technologies, is 42 minus our mean. So we're choosing this number, which is our x value, minus 37 divided by 1.6. That's going to give us 3.13. So looking at all these z-scores, the category you should concentrate on is data processing. That's for lowest z-score. Right. Question 3. Mortgage statistic indicates the number of years that a new homeowner will occupy a house before moving or selling is normally distributed with a mean of 8.2. So again, this is your mean. And a standard deviation of, say, 2.1. Find the probability of the nearest thousand of each event. So a homeowner will sell or move within 4 years of buying the house. So remember, we need to figure out if we need to use a empirical rule first, or are we okay using our calculator? So if I draw my empirical rule, I'm giving my mean, which is 8.2, and my standard deviation is 2.1. So I'm going to add 2.1 to each of up to 1 standard deviation. So 8.2 plus 2.1 is 10.3. Next, standard deviation, so I'm adding 2, it's 12.4. And then the last one is 14.5. And on this side, I'm going to subtract 2.1. 5.2 minus 2.1, 6.1, 4, and 1.9. Now, do I have 4 on my graph? Yes, I do. It's right here. Okay. So it's saying the homeowner will sell or move within 4 years. So not more than 4 years, but within. So we're going to have 4 or less. So just a quick reminder, I don't know if you guys recall the percentages. And again, the formula is given to you on a formula sheet. But this is 34%. This is 13.5. This is 2.35. And this is 0.15. So I'm only going to add these two. So 0.15 plus 2.35 because it's all less than 4. That should give you 2.5%. Now question B says 99.7% of the homeowners sell and move between what two amounts of years. So again, a reminder that one standard deviation from the middle, it's always 68%. 2 standard deviations from the middle, it's 95%. 3 standard deviations from the middle is 99.7%. So we are in between 1.9 and 15.5. Okay? And then the last question says the homeowner will sell or move after 5 to 7 years buying the house. So again, I'm looking at my empirical rule. I do not have 5. 5 will be somewhere here. And I do not have 7. So we cannot use the empirical rule, but what we can use is our calculator. We're going to use an option second vars. Second option. And we're between 5 and 7 years. So let's go back to our calculator here. Alright, so remember, we're going to use second vars, second option, which is normal CDF, enter. Now we have a lower bound, upper bound, mu, and standard deviation. So going back to here, lower bound, upper bound, mu, and standard deviation. The lower bound, of course, between 5 and 7. 5 will be our lower bound, 7 will be our upper bound. Our mu was given to us as 8.2, and our standard deviation was 2.1. So plugging this all into the calculator, 5, 7, 8.2, 2.1, and pressing enter. Okay, we get 0.2200. So our answer is 0.2200, so that's 22%. So 22% of people, homeowners will move or sell the house after between 5 to 7 years. All right. Question 4. It says, tests show that a certain model of new cars has an average of 41 miles, so that's my mu, that's 41. And a standard deviation of 4. Okay. Assuming the distribution is normal, find the probability. So, more than 50 miles. So again, I have to make sure I'm going to do empirical rule first and check if those numbers are. So I got 50. Okay. Now, I start with, I start with 41. Okay. And then I will add my standard deviation to each. So add 4, it's 45. Add 4 is 49. Add 4 is 53. Now the other way around, I'm going to subtract 4. That's 37. Subtract 4, that's 33. Subtract 4, that's 29. Now, do I have 50 on here? I do not. 50 will be somewhere in between there. Okay, so that means I cannot use empirical rule. I have to use my calculator. So lower bound, upper bound, mu, and standard deviation. So I know my mu and my standard deviation, so 41 and 4. Now, I am asked for more than 50 miles per gallon. So more than, that means it cannot be less than 50. So 50 has to be my lower bound. And remember, if we don't have an upper bound, we're going to use a number 1 more. Okay, now we want to go back to our calculator right here. Plug it in. Okay, let me do that. We're going to go second bars, second option. Alright, so my lower bound was 50. My upper bound was million. My mute was 41. My standard deviation was 4. Press enter, enter. I got 0.0122. 0.0122. Okay, so that is going to be 1.22%. Now, 1.22%. Okay, now, the second part of it, B, says 95% of cars average between what two amounts of mileage. So we know that 95% indicates that I'm going to use my empirical rule. So again, the first two, it's 68. You get 2 standard deviations from the middle, it's 95. So what are those numbers? 33 and 49. So between 33 and 49. Okay. All right. Next question, number 5. Scores on the midterm were normally distributed between a mean. So then again, this is your mean of 65 and a standard deviation of 8. So again, I'm gonna do my empirical rule to check if my numbers are on. All right. So I got mean of 65. 1, 2, 3. I'm adding 8. So it's going to be 73, 81, and 84. I'm going to subtract 8. That's 57, 49, and 41. Alright, so 81. Do I have 81 here? Yes, I do. That is right here. Now it says it's less than or equal to 81. So all the numbers going this way. So again, just a reminder, this is 34%, 34%, 13.5, 13.5, 2.35, and 0.15. So I'm going to add all these numbers together to see what percentage I got. So I'm adding all of that because that is what I'm looking for here, okay? So you should have gotten 97.5%. All right, and then for part B, of course, again, we're looking at 95% of the data fall between what scores? So again, this is 68%. It's 1 standard deviation from the middle. 2 standard deviation from the middle is 95%. So these numbers are 49 and 81. All right, moving on to question 6. Annual rainfall in Alaska town is normally distributed with a mean of 150. So again, this is your mean per year and a standard deviation of 36. So your mean is 150, standard deviation 36. What is the probability of rainfall? At least 100 inches. So again, I am going to see if I need empirical rule. Okay, so we have 150 here. Since I'm looking at least 100, I'm going to try to go to the left, see if I have 100 here. So 150 minus 36, it's going to be 114. And then 114 minus 36 is 78. So no, I do not have a 100. 100 will be somewhere in the middle, so I cannot use empirical rule, but I can use my calculator. So lower bound, upper bound, mu, that's 150. Standard deviation is 36. Of course, if we're doing at least 100 inches, it means I cannot have 99 inches. It has to be 100 or more. So 100 is my lower bound, and 1 million will be my upper bound. So going back to my calculator, we're doing second bars, second option. Okay, so again, 150. Nope. What was my lower bound? 100 was my lower bound. Okay, million was my upper bound. 150 was my mean, and my standard deviation was 36. Right, so 91.75 and 91.76. So it's 0.9176, which is 91.76%. All right, and now between 200 and 300. So again, can I use the empirical rule? Let's check. I got 150. So plus 36 would be 186. Plus 36 would be 222. So again, 200 would fall in between. So I cannot use my empirical rule. I'm going to go back to calculator. So lower bound, upper bound, mu and standard deviation. Lower bound, of course, is the lowest number, which is 200. 300 is my upper bound. Mean is 150, and standard deviation is 36. So, putting it back in the calculator, second bars, second option. Okay, lower bound is 200, upper is 3, mean and standard deviation stay the same. We get 0.0824. So 0.0824, which is 8.25%. All right. Next question. All right. So here we've got a dot plot. And first question says a randomly sampled senior students were asked for their GPA from two schools. What is the mean for school A? So what I did was I plugged in all these data into the calculator. So we have 1, 0.0, we have 1, 1, 1, 1.5, and 1, 2. We got 3 2.5s. We got 6 3.0s. We got 4 3.5s and 3 4.0. So this is what I did. Went back to the calculator. Alright, clear that, go to stat, go to edit, and delete the data I got. So again, according to our data, we had 1 0.0, 1 0.5, 1 1, and then 1 1.5. Okay, next I had 3, nope, I had 1 2.0. Now 2.5 was 3 times, so 2.5, 2.5, 2.5. 3 was 6 times. 1, 2, 3, 4, 5, 6. 3.5 was 4 times. And 4.0 was 3 times. Okay, so now go to stat, move to calculations, first option, list matches. All right, so they're asking us what was the mean for school A. It was 2.69. Oh, did I make a mistake? Let me go back to my list very quick. Yep, we don't have 0. See, I made a mistake. We do not have 0.2, 0.5 on the list. So I'm going to go down and delete that one. We only have 0 and then 1. So now back to stat, calculate. There you go. 2.8 is our mean. I'll put into my notes. 2.8 is our mean. Okay. Now the second question says which statement correctly compares the standard deviation of two schools. So we already know that school A standard deviation is given to us right here. It's 1.005. 1.005. Now I'm going to do the same thing and do 3 of these 3 of these, and so on in my data, and put it in my calculator here. So again, stat, edit, I'm going to delete the data I got. Alright, and put 1 3 times, 125 3 times, 2 3 times, 5, 2.5 is 4 times, and then 3 4 times, and lastly 3.5 is 6 times. Insert calculations version. Alright, so now our standard deviation here is 0.827, 0.828. So school B is 0.828. Okay, so which statement correctly compares the standard deviation? Where did that standard deviation of the school A is smaller? That is not true. Standard deviation of the school B is smaller. That is correct. Okay, and the standard deviation of the AB is the same, and the relationship between cannot be determined. So, all right. All right, question 8. On a local highway, average speed is 68, and standard deviation is 4. Assuming the speed normal distributed, the z-score for cars going 65 miles an hour. So again, 65, so z-score is x minus the mean divided by standard deviation. So we're just going to plug it in. 65 minus 68 divided by 4 should give you negative 0.75. Okay. Question 9. A company mean salary is $65,000 with a standard deviation of 6,000. Okay. Now, question 8 is asking 68% of the salaries fall between what two amounts? So $68, so I gotta make a graph of empirical rule. Again, I start with 65,000. In the deviation, I'm going to add 6,000, it's going to be 71,000. I'm going to add another 6,000, it's going to, well, actually 60%, I don't even have to do that. I can just do one standard deviation on each side. I'm going to subtract 6,000, that's 59,000. So if it's asking you for 68%, this is for 68%. One standard deviation on each side, right? So the numbers we talking about is 59,000 and 71,000. The correct answer is C. Now the B part is saying what is the probability that the employee makes at least 68,000? Okay, so again, right here 68,000, I can tell if I was somewhere in between here. So I have to use my calculator, lower bound, upper bound, mu, and standard deviation. That's 65,000. That's 6,000. Now, it says at least. It makes at least, right? So it cannot make less than 68,000, which means 68,000 again. It's our lower bound, and upper bound is going to be a million. Again, plug it into our calculator. I'm going to go to the second verse, second option. Right, so 68,000. So lower bound. Million is going to be upper bound. 65,000 is our mean, and 6,000 is our standard deviation. Right, so it's 30, 85, which according to our answers, is answer A. Bye-bye.